So hello and good morning, class. Okay, so may may I request everyone to please stand for our prayer. And since Bennett is the prayer is the one who prayed yesterday, so Jeffrey, it's your turn to pray in front. Amen. Okay, so thank you, Jeffrey. So before you So before you before you go sit down, can you please pick all pieces of paper around you and around this class the beam, and also please arrange your chairs properly. And then let me now sit down. Okay, so I see there's no trash around here, and looks like it's rearranged, so you may now sit down. Okay, so now let's check your attendance. Say present when your name is called. Ada, Bennett, Yoko, and Zane. Okay, so I see everyone is all present today, so that's great, class. Okay, so now you are guys exciting to our for our new lesson. But before we go to our new lesson, let's first to take a review to our previous lesson. So please look at here to my presentation right here. So we'll, we will do a review to our previous lesson in a way of an activity. Okay, so since yesterday we talked about the trigonometric ratios on right triangles and special angles, particularly focus on the SOHCAHTOA, which is the sine, cosine, and tangent. Now, let's have a review in an activity. So, all you have to do is just answer the following. And I'll give you a 5 minutes to answer this. Okay, so all done? Okay, so let's check if your answer is correct. So let's have number one. Given that given that A is equal to 1, B is equal to 3, and C is equal to 5, find the sine, cosine, and tangent. So what is the sine? Correct. It's 1 1 over 5 because sine is equal to opposite over hypotenuse. So the opposite leg there is 1 while the hypotenuse is 5. So that's why 1 over 5. Next, cosine. Yeah, correct. It's 3 over 5 because cosine is equal to adjacent over hypotenuse. So the adjacent leg there is the number 3 while the hypotenuse is 5. Okay. So last one, tangent. Okay, very good. It was 1 over 4, 1 over 3. It's 1 over 3 because that tangent is equal to opposite over adjacent. So the opposite leg there is 1 while the adjacent leg there is 3. Okay? So that's correct. Next, number 2. What is the sign? Very good. It's 2 over 6, or we can simplify it as 1 over 3. Okay. Next, number 2. Next, cosine. Very good. It's 4 over 6, but we can simplify it as 2 over 3. Okay. Lastly, tangent. Very good. It's 2 over 4, or we can simplify it as 1 over 2. Okay. So next, number 3. Given that the sine 60 degrees and hypotenuse is equal to 11, find the opposite leg and the adjacent leg. So, what is the opposite leg? Anyone? Okay, very good. So let's see. So sine 60 degrees times 11 is equal to, okay, so the opposite leg is 11 times to the square root of 3 all over 2. Now, what is the adjacent leg? Very good. You just simply use the Pythagorean theorem. So it's so we use the Pythagorean theorem, and we have 11 over 2. So the adjacent leg is 11 over 2. Okay. Next, number 4. What is the adjacent leg? 1. Very good. So to solve this is, first up, you just need to find the tangent the of 45 degrees. And the tangent of 45 degrees is 1. So 1 times 1 times A is equal to 1 is equal to A. 1 times A is equal to A. So we left the opposite times the 1 is equal to 5. So the adjacent leg is 5. Now, what is the hypotenuse? Okay, good. Use the Pythagorean theorem. So 5 squared plus 5 squared, and we square root at all. The result is 5 square root of 2. Okay, so that's good. That's good. Okay, so since we now refreshed our minds to our past activity, on our past lesson, so it's time so now it's time for you to know about our new lesson. So we will now ta- we are now discussing about trigonometric ratios of right triangles and special angles, but we are now focusing on the Choshakal. Okay, Choshakal, which is the second three trigonometric ratios, which are the cosecant, secant, and cotangent. So the lesson objectives of this of this lesson is, at the end of the lesson, the students are expected to, one, use the trigonometric ratios cosecant, secant, and cotangent or choshakaw on a right triangle problems. Number two, measure the sizes of right triangles by the trigonometric ratios cosecant, secant, and cotangent or choshakaw. And number three, the last one, show the value of perseverance in doing activities related to trigonometry. Okay? So, so we do before we discuss the topic further, let's have some a activity. Have some an activity. And this activity is just a motivation activity. Let's see if how all of you are well known or have a prior knowledge about this lesson. So you can now answer the motivation activity. So I'll give you 5 minutes to answer this. Okay, all are done. Okay, so so you may now, so let's see if of you correct. So I have here the correct answer. Okay, so for the number one is the cosecant alpha is equal to 11 over 7 or 1 4 1 1 4 over 7. Then secant alpha is equal to 11 over 9 or 1 2 over 9. Cotangent alpha is 9 over 7 or 1 2 over 7. Okay. For number 2 is 12 over 8, or we can simply as 3 halves, 3 halves or 1 half. Then for the cosecant alpha, then secant alpha is 12/10, or we can simply as 6 over 5 or 1 over 5. Then the cotangent alpha is 10 over 8. We can simply as 5 over 4 or 1 over 4. Next, for the number 3, the hypotenuse is 4 square root of 2 and the opposite leg is 4. Then number 4, op the opposite is leg is 6. Then the adjacent is 6 square root of 3. Okay? So, so is any one of you got the correct, got everything correct? Oh, so there's some of you got the correct answer, but everything correct answer, but some of you are not. So let's have some a let's have clarify all of your misconception about on this activity. So let's start with number one. Let's start with number one. Given that A is equal to 7, B is equal to 9, and C is equal to 11, find the cosecant, secant, and cotangent. So, how to solve this problem in the right way? Very good. So we know all the correct answer. So I'll show you what is the correct way of answering this problem. So we all know that A is equal to 7, B is equal to 9, and C is equal to 11. So to find the cosecant of this of the given is what? You have to use cosecant alpha is equal to hypotenuse over opposite leg. Or and we can say it's is equal to C over A. Then is equal to The C there is 11. Then the A there is 7. So that's why cosecant alpha is equal to 11 over 7 or 1 1 4 seventh. 4 sevenths. Okay? Okay, so next, for the second alpha, we will use second alpha is equal to hypotenuse over adjacent, where we can basing on the given, we changes as C over B. So the C there is 11, the B there is 9. So second alpha is equal to 11 over 9. Or we can say as 1 2/9. Lastly, the cotangent alpha. The cotangent alpha will solve it to cotangent alpha is equal to adjacent over opposite, or we can simply ask B over A. So, so the B is 9, the A is 7, so the cotangent alpha is equal to 9 over 7 or 1 2/7. Okay? That's the correct way of solving the number 1. That is the same way how we solve on number 2, where the given there, where we still same to find but different given, where A is equal to 8, B is equal to 10, and C is equal to 12. Where for the cosecant, for cosecant alpha, is so we still know that cosecant alpha is equal to hypotenuse over opposite leg is equal to C over A, so is equal to 12 over 8, but we can simplify it. So is equal to 3 over 2 or 1/1/2. For second alpha is equal to hypotenuse over adjacent is equal to C over V is equal to 12 over 10. So we can simplify it is will become 6 over 5 or 1/1/5. And lastly, cotangent alpha. Cotangent alpha is equal to adjacent over opposite is equal to B over A is equal to 10 over 8 is equal, or we can simplify it. We can simply ask 5 over 4 or 1 over 1/4. Okay, so that's the right way of answering number 2. So now for the number 3 and 4. For the number 3 is given that second second 45 degrees and adjacent leg is equal to 4, find the hypotenuse and opposite leg. Now, well, the number 4 is given that cosecant 30 degrees and hypotenuse 12, find the opposite leg and adjacent leg. So here how we solve them in right way. For number 3, given is secant 45 degrees and A is equal to 4. So to find the hypotenuse, we have to use secant alpha is equal to hypotenuse over adjacent. Then we have to substitute everything of it. So it will come secant 45 degrees is equal to hypotenuse over 4. Then the next thing to do is to cross multiply. So it will become h times 1 is equal to secant 45 degrees times 4. So let's evaluate them. H times 1 is equal to h. Then secant 45 degrees is equal to square root of 2. Then times 4. Then the next one is h is equal to square root of 2 times 4 is equal to 4 square root of 2. So the hypotenuse is equal to 4 square root of 2. Now, to find the opposite leg, we will use the Pythagorean theorem. So it's hypotenuse squared is equal to opposite squared plus adjacent squared. And since we are looking for the opposite, so we have to change the formula into this. opposite squared is equal to hypotenuse squared minus adjacent squared. Then, to make it more, to make it find the correct one, we just need to square it on both sides so that the squared on the opposite will be erased, will be cancelled. So it will left as opposite, while the right hand will be stayed. And after that it's time to substitute everything up. So opposite is equal to the square root of the hypotenuse is 4 square root of 2 squared minus the adjacent is 4. So 4 squared. Then evaluate that. 4 opposite is equal to 4, the square root of 4 square root of 2 squared is equal to 32 minus the 4 squared is equal to 16. Then next is opposite is equal to square root of 32 minus 16 is 16. So so the square root of 16 is 4. So the opposite leg is equal to 4. Now, for the last one, the given there is cosecant 30 degrees and hypotenuse is equal to 12. So we all know that the formula of cosecant is cosec. So we know that the cosecant will formula is cosecant alpha is equal to hypotenuse over opposite. So substitute everything up. Cosecant 30 degrees is equal to 12 over opposite. Then cross multiply, it will become cosecant 30 degrees times opposite is equal to 12 times 1. Then evaluate it up. Cosecant 30 degrees is equal to 2. So 2 times O is equal to 2O. Then 12 times 1 is equal to 12. Then after that is to make this O will stay as O, we have to let the let the 2 divide let the number 2 divide both sides. So 2O 2O divided by 2 is equal to 12 divided by 2. So cancel the same number. So that will be left at, so that the O will be now, so that the left hand will be now left with opposite leg. While the on the right will have to evaluate it. 12 over 2 is equal to 6. The opposite leg is equal to 6. Now, to find the adjacent leg, so we will now use the Pythagorean theorem. So hypotenuse squared is equal to opposite squared plus adjacent squared. And since we are finding the adjacent, so we have to derive it. It become adjacent squared is equal to hypotenuse squared minus opposite squared. Then we have to square root on both sides, so that the adjacent will be let so that a squared will become so that adjacent squared will become adjacent, and while the other's hand will be stayed the square root. And now substitute everything up. So adjacent is equal to the square root of the hypotenuse is 12. So 12 squared minus the opposite leg is 6. So 6 squared. Then let's evaluate that. 12 squared is equal to 144. 6 squared is equal to 36. Then 144 minus 36 is equal to 108. So the square root of 108 is 6 square root of 3. So the adjacent leg is 6 square root of 3. Okay? So, do you have any questions for clarifications in this? Anyone? If none, then let's go now. Let's go dig deeper to this lesson. Let's go. Let's now have the lesson proper. So let's start up with trigonometric ratios of right triangles using Chauchat. So, first up, so you still remember the parts of the right triangle, right? Okay. So let's incorporate the parts of the triangle on the second three of the trigonometric ratios. So here are the formulas. For the formulas of the cosecant, secant, and cotangent. So cosecant for the alpha angle is cosecant alpha is equal to hypotenuse over opposite leg or C over A. Then in the beta side is cosecant beta is equal to hypotenuse over opposite leg is or we call as C over B. Then secant alpha is equal to hypotenuse over adjacent leg, and that is C over B. And while in the beta is C over A. And lastly, cotangent alpha is adjacent over opposite, where will come B over A. But in a beta will now form into A over B. Reason, so we have to guys need to be careful that if the angle is alpha, then the opposite leg will the opposite leg side is the A, the adjacent leg side is the B, and the hypotenuse is C. But when it comes to the beta angle, then the opposite leg side will be the B, while the adjacent leg side is the A, and the hypotenuse is the C. And to make it to make it more easier to remember, this is the mnemonics of these formulas. Choshakao, where means that it means that cosecant hypotenuse opposite, secant hypotenuse adjacent, and cotangent adjacent and opposite. Or if we correct it cosecant is equal to hypotenuse over opposite leg, then secant is equal to hypotenuse over adjacent leg, and cotangent is equal to adjacent leg over opposite leg. Okay? So, so we notice that in our calculators that we don't see any button for the cosecant, secant, and cotangent, right? Right? So you guys see it? Okay. So to calculate the cosecant, secant, and cotangent using in our calculator, we have to know about their reciprocal identities. And this is the reciprocal identities. So for the cosecant, for the cosecant is equal to 1 over sine. Then secant is equal to 1 over cosine. And lastly, cotangent is equal to 1 over tangent. Remember that cosecant is the opposite of cosecant, or the reciprocal of cosecant is sine, while the secant is cosine, and the cotangent is tangent. So that means if you want to calculate the cosecant, secant, and cotangent, you have to you are just to use the sine, cosine, tangent, but you have to put it on the denominator and put one as on the numerator, or we call it in a fraction form, but put the sine, cosine, and tangent on the denominator. Okay, so let's have some examples. For example number 1, find the trigonometric ratios cosecant, secant, and cotangent of alpha if A is equal to 6, B is equal to 8, and C is equal to 10. So, here is the correct solution. The solution of this. Cosecant alpha is equal to C over A. So, the C is 10, the A is 6. The A is, oh my God, looks like oh my God, looks like I supposed to put wrong. So, supposed to be, it's 6. This one is 8. Okay, okay. Okay, so here's the correct one. The C is 10, so the A is 6. So the cosecant alpha is equal to 10 over 6 or 5 over 4. For the second alpha is C over phi, so C is 10, B is 8, so second alpha is equal to 10 over 8 or simplify it as 5 over 3. Then the last one is the cotangent alpha. Cotangent alpha is equal to B over A. So the B is 8, the A is 6. So cotangent alpha is equal to 8 over 6 or 4 over 3. So, so the answer are cosecant alpha is equal to 5 over 4. Wait. Okay, so this is the correct one. So cosecant alpha is equal to 5 over 3. Second alpha is 5 over 4. And the cotangent alpha is 4 over 3. Okay, so next up, for the second example is, let's have, this is a different one. Like if, when in the first example, I am giving you the all sides and you just need to find the cosecant, secant, and the cotangent. Now, what if I only give the sec, I only give only one trigonometric ratio. So this is the example. Given that secant beta is equal to 2.6, find the trigonometric ratios cosecant and cotangent. So to solve this, so secant beta is equal to 2.6. So you have to you have to turn this up, turn this turn this decimal into fraction to know the to know the hypotenuse and the adjacent. So 2.6 is equal to 13 over 5. So that means the C or the hypotenuse is 13, while the A or the A or the adjacent is 5. So since we are known now what's the C and the A, now we have to find the letter B by using, correct? It's Pythagorean theorem. So C squared is equal to A squared plus B squared. Since we are finding the B, so it will become B squared is equal to C squared minus A squared. Then to make it, then we have to turn this up into the B squared into just B. So we have to square root on both sides and it will become B is equal to square root of C squared minus A squared. So let's substitute them. B is equal to square root of the C is 13, so 13 squared, minus the A is 5, so it's 5 squared. And let's evaluate it. 13 squared is equal to 169. 5 squared is equal to 25. Then 169 minus 25 is equal to 144. And the square root of 144 is equal to 12. So the B is 12. And now, since we know the all sides, which is A is equal to 5, B is equal to 12, and C is equal to 13, now it's time to find the cosecant and the cotangent. So for the cosecant, so cosecant beta is equal to C over B. So that means C is 13, B is 12. So that means cosecant beta is equal to 13 over 12. And lastly, cotangent beta is equal to A over B, wherein A is 5, then B is 12. So, so the answer is cotangent beta is equal to 5 over 12. So, this is the correct answer. Cosecant beta is equal to 13 over 12 and cotangent beta is equal to 5 over 12. Okay? So, do you have any questions for the first concept? If none, then let's move on to the second and last concept, which is trigonometric ratios of special angles using Chauchat. So, so can someone recall what are the special angles? Very good. It's 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Only for right triangle. Okay? So, this is the table to know their their appropriate the correct answer of every angle in every trigonometric ratio. So for the cosecant 0 degrees is undefined. Cosecant 30 degrees is 2. Cosecant 45 degrees is square root of 2. Cosecant 60 degrees is 2 square root of 3 all over 3. And cosecant 90 degrees is 1. Then secant 0 degrees is then secant 0 degrees is 1. Secant 30 degrees is 2 square root of 3 all over 3. Then secant 45 degrees is square root of 2. Then secant 60 degrees is 2. Then secant 90 degrees is undefined. And lastly, cotangent 0 degrees is undefined. Cotangent 30 degrees is square root of 3. Cotangent 45 degrees is 1. Cotangent 60 degrees is square root of 3 all over 3. And cotangent 90 degrees is 0. Okay? So since we know now what are their their value of every trigonometric ratios and the angles, let's move on to some examples of it. Example number 1. Given that cotangent 45 degrees and the opposite leg is equal to 2, find the adjacent leg and hypotenuse. So here's the solution. So we know that cotangent alpha, so we know that the cotangent is equal to adjacent over opposite. So let's substitute everything up. So so the angle is 45 degrees. So cotangent 45 degrees is equal to adjacent over the opposite leg is 2. Okay? So next up, we have to cross multiply and become A times 1 is equal to cotangent 45 degrees times 2. So So if we, let's simplify it up. A times 1 is equal to A, then cotangent 45 degrees is 1 times 2 is equal to 2. So the adjacent leg is equal to 2. Then to find the hypotenuse, we'll just need to use the Pythagorean theorem, which is hypotenuse squared is equal to opposite squared plus adjacent squared. Then we have to use squared on both sides so that it will left the h squared into h. Then, so we come h is equal to square root of opposite squared plus adjacent squared. Now let's substitute everything up. Opposite is square is 2, so 2 squared plus the adjacent leg is 2 also, so 2 squared. So hypotenuse is equal to square root of 2, so 2 squared is 4. So 4 plus 4 is equal to 8. So square root of 8 is 2 square root of 2 or approximately to 2.83. So the answer are the adjacent leg is 2 and the hypotenuse is 2 square root of 2 or approximately to 2.83. So next, example number 2. Given that secant 60 degrees is equal to given that secant 60 degrees and the hypotenuse is equal to 14, find the adjacent leg and the opposite leg. So we know that the the second the formula of secant is hypotenuse over adjacent. So we have to substitute everything up. So second, the angle is 60 degrees is equal to the hypotenuse is 14, then all over adjacent. Then cross multiply them. It will become secant 60 degrees times alpha times adjacent is equal to 14 times 1. Then we have to simplify them all. Secant 60 degrees is equal to 2. Then 2 times A, 2 times adjacent is equal to 2 adjacent. Then 14 times 1 is 14. Okay? Then to make to make the A or the adjacent alone, we have to divide both sides by 2. So the 2A over 2A, so the 2 will be now canceled, so it will left as A or the adjacent. Well, the other side, so A is equal to the 14 over 2 is equal to 7. So the adjacent leg is 7. Then next, to find the opposite leg, we will now use the Pythagorean theorem. So hypotenuse squared is equal to opposite squared plus adjacent squared. And since we are finding the opposite leg, so we have to change it into opposite squared is equal to hypotenuse squared minus a up adjacent squared. And square root on both sides to square root of both sides to become opposite leg is equal to the square root of hypotenuse squared minus adjacent leg squared. So substitute them. Hypotenuse is 14, adjacent is 7. So opposite is equal to square root of 14 squared minus 7 squared. Then 14 squared is equal to 196. 7 squared is equal to 49. So 196 minus 49 is equal to 147. So square root of 147 is 7 square root of 3 or approximately to 12.12. So the answer are the adjacent leg is 7 and the opposite leg is 7 square root of 3 or approximately to 12.12. Okay? So, do you have any questions? If none, Then we have some a group activity. So please go to your 5-member groupings. I already created. Okay. So so find your places and be sure to have a one hole for for your solutions and your answers. Okay. So now take a picture for the first part of our group activity. So all all groups must picture the first part of our group activity. Okay. Okay. All now have been pictured. Okay. So take a picture of the second part of our group activity. Okay. So everything is being pictured. Okay. So it's just simple. You just need to answer everything up, and but be sure to show your solutions. So solutions how you come up to that answer. So I'll give you 10 minutes to answer them. Okay, so everybody's done. Okay, let's check. So let's check. So for the number one is find the trigonometric ratios cosecant, secant, and cotangent of alpha if A is equal to 7, B is equal to 24, and C is equal to 25. So what is the cosecant? Very good. It's 25 over 7. Then what is the secant? Very good. It's 25 over 24. And lastly, what is the cotangent? Very good. It's 24 over 7. So next, number 2. Given that cotangent beta is equal to 11 over 60, find the trigonometric ratios cosecant and secant. So, we know that the cotangent beta is equal to B over A. So we all know that the cotangent beta is equal to A over B. So that means that A there is 11 while the B there is 60. So so use the Pythagorean theorem to find the letter C, and it was what? Very good. It's very good. It's 61. Okay, so now use everything up to find the cosecant and secant. So what is the cosecant the cosecant beta? Very good. It's 61 over 60. Then the second, very good. It's 61 over 11. Okay. Okay. So next up, for number 3, given that cosecant 30 degrees and hypotenuse is equal to 20, find the opposite leg and the adjacent leg. So what is the opposite leg? Very good. Very good. So, using your calculator, 1 over cosecant is what? What? The reciprocal. Very good. It's 1 over sine. So 1 over sine 30 degrees is equal to 2. So 2 times opposite. So 2 opposite, then 20 times 1 is equal to 20. So so divided by both sides, so that will come opposite leg is equal to 10. Opposite is equal to 10. Correct. So now use the Pythagorean theorem to find the adjacent leg, and it become what? Very good. It's 10 square root of 3. So the adjacent leg is 10 square root of 3. Now, let's go to number 4. For number 4 to 6 is an application of the lesson. So for number 4, suppose you are designing a support structure for a triangular billboard. The three sides of the triangular billboard are represented by the lengths A, B, and C. If the lengths of the sides are known to be A is equal to 9 meters, B is equal to 40 meters, and C is equal to 41 meters, determine the trigonometric ratios cosecant, secant, and cotangent of the angle alpha. So we are already see the given that the the A there is 9. The A is equal to 9 meters, B is equal to 40 meters, C is equal to 41 meters, and we are finding the alpha angle of cosecant, secant, and cotangent. So what's the answer? Very good. The cosecant alpha is equal to 41 over 9. Then the second alpha is equal to 40 over 9. And lastly, no, 41, no, second alpha is equal to 41 over 40. And lastly, cotangent alpha is equal to 40 over 9. Okay? Now next up, number 5. Imagine you are an engineer analyzing the tension forces in the cables of a suspension bridge. The angle of inclination of one of the cables, denoted as beta, is crucial for understanding the structural integrity. If it is known that the cosecant of the angle beta is equal to 37 over 35, your task is to calculate the secant and cotangent of the same angle. So, what is the so we are known that the cosecant beta is equal to the to the hypotenuse over adjacent, right? So to find the missing one, we have to use the Pythagorean theorem. And it was what? Very good. It's 12. Now let's use them all to find the secant and cotangent. So so secant beta. So secant beta is equal to 37 over 12. And lastly, 12, right? Because remember that 37 is the hypotenuse, so that's the letter C. While the 12 is the adjacent, so that's the letter A. And lastly, for the cotangent beta, right? Correct? It was 12 over 35 because cotangent beta is A over B. So the A there is 35 and the B there is 12. So, okay. Okay, so the last one, number 6. Imagine you are a surveyor tasked with determining the dimensions of a ramp that is inclined at an angle of 45 degrees of cotangent. You have measured the length of the adjacent leg or the horizontal distance to be 7 units. Your goal is to calculate the length of the opposite leg, which is the height of the ramp and the hypotenuse of the ramp or the inclination. So we know that, so the given are that cotangent 45 degrees, then the adjacent leg is 7 units. So we are finding the opposite leg and the hypotenuse. So we use so what's the answer? Okay. So 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 cotangent 45 degrees is equal to 1. Then 1. Then 1. Then 1 over O, 1 times O, so it's 1, so just O, so that means the adjacent leg, so the opposite leg is 7 units also. Then, then for the hypotenuse, we use the Pythagorean theorem, and that is 7 square root of 2. Okay, so you got it all right now. So, so now, now before we go to our to some a and some assessment, some assessment for you, an assessment task for you, as I'm asking you a question, some questions. What are your feelings and thoughts on the activities we just completed? One, yes. Okay, okay, that's good. What else? Yes. Hey, that's good. So so in doing this activity, so since I put on the objective number 3 is show the value of perseverance in doing the activities. So that means so that's why when you guys do the activity earlier, you guys show the value of perseverance because all of you took a lot of effort to find the correct answer of every problem, even though it was even though the solution of finding that is a bit more complex to you in your graph, right? Okay, so next up, could someone recall the formulas of the cosecant, secant, and cotangent with the minutes of them? Yes. Okay, very good. So we just simply derive it as Chosha cow, or what or cosecant is equal to hypotenuse over opposite leg, then secant is equal to hypotenuse over adjacent leg, and cotangent is equal to adjacent leg over opposite leg. So now, can you what are the 5 trigonometric special angles we used? Yes? Very good. It's 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So, may I ask you, why is it important to us to learn this lesson? Anyone? Can someone have a little explain on this? Yes? Okay, okay. What else? Yes? Hey, okay. So so the reason why we learn this lesson is because is it's just because we are incorporate this one when we are dealing to some any objects that in relation to the any objects that are right triangle that to find some correcting the measurements so that any objects are not become not be destroyed. Like example, what if we make some a ramp? Example, we have the examples here, the ramp, or what if a put some structure that is a triangular form or particularly in a right triangle form. So so in in doing this lesson in having this lesson we are helping we are knowing us how to find the correct measurements so that any objects will not be destroyed directly on a one single wrong measurement. Okay, so do you have any other questions? None. Okay, so it's time for some assessment. So get one whole sheet of paper and answer directly. And remember, this is an individual quiz. Individual quiz, so it will be part of your written works. And this is a 20 points. This is a 20 points. Okay, so I'll give you 15 minutes to answer this. Okay, you have 5 minutes left. Okay, you have 1 minute left to answer. Okay, time's up. Pass your papers and pass your papers and Write your papers to me in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 1/2, and 0. Okay, so looks like all of you have been submitted now. So we will know we will know the answers of this assessment tomorrow. So this assessment tomorrow, and also tomorrow I'll I'll bring this paper back to you, and you will now see the result. And we have do something a short explanation of your of your of the assessment to I think to know your mistakes and your misconceptions and mistakes on what you answered. Okay, so before we end our class, I'll give you a an assignment. So this is your assignment. So can we now take a picture of it, please? So for your assignment, this is an individual task. Create your own one solutions of the right triangles, a real-life application worded problem with complete and correct solution and answer with conclusion. Write this in a one whole sheet of paper, and the deadline of of this assessment is tomorrow. So I'll be expecting that everyone will submit to me tomorrow when we start the class on our period. Okay? And you have to complete this complete this assessment because this is a 30 points on your written works. Okay? So that's it. That's it. That is all. That's it. That's the end of our class. So that's all, and thank you and goodbye. Goodbye, class. Okay.